Welcome to the Digital Enterprise Society podcast, addressing all aspects of the digital enterprise, inspiring connection without boundaries and creation without limits. Thank you for tuning in. Here are your hosts, Thom Singer and Craig Brown.
Hey, and welcome back to the Digital Enterprise Society podcast. Thank you so much for coming along on the journey of this podcast that has been designed to be a resource for those who work in and around PLM. The Digital Enterprise Society, it is a forum for the exchange of ideas surrounding the tools, processes, and practices used across the product lifecycle. To learn more, check us out at digitalenterprisesociety.org. My name is Thom Singer, and I have the honor to co-host this show with Craig Brown. Craig is an industry veteran and former PLM leader at General Motors. Hey, Craig, how are you today?
I'm great, Tom. We're in the middle of summer. It's hot.
Doesn't matter where you are. It's the middle of summer.
That's right.
That's right. So every single week, Craig and we try to bring to this podcast really interesting interviews and ideas that are going to help the listeners enhance and grow their careers. And today is going to be one of those shows. Today, we are joined by Kevin Brittain. Now, he is the multidisciplinary group lead at Cummins. And what he does is he sort of coaches a team that is focused on bringing cross-functional models to solve problems across the product lifecycle. Hey, Kevin, welcome to the Digital Enterprise Society podcast.
Hey, Tom. Hey, Craig. Thanks for having me. Really appreciate it.
So, I don't read like the bios that the fancy PR people send along. So could you tell everybody a little bit more about your journey and how you got to what you're doing today?
Yeah, sure. I'll start from the very beginning. I went to the University of Evansville. Was there for 4 years, studied mechanical engineering. Moved on there to the University of Illinois, where I studied mechanical engineering as well. But I had a focus on structural optimization at that point. And I've always been enthused, especially it really began in my undergrad when I was doing some of my internships and co-ops. I got the opportunity to kind of create new designs and do my own analysis. And I was just totally enthralled by that process of creating something, analyzing, improving, et cetera, et cetera. And so when I got to grad school, I learned that, hey, computers can actually help you do this better than this manual way over and over again. And I was just hooked from there on. And so, fortunately, I ended up at Cummins, and I entered Cummins as a structural analyst, dynamics analyst, and I was kind of doing this optimization stuff, the things that I learned in school on the side, more as extracurricular work, and then that has evolved over the years into my full-time job, and I actually get to lead a group doing those things now. So that's me.
So Kevin, I heard you present it at well, some people would say the event of the year for simulation guys, right? For years, it's been known by NAFEMS. The name I caught this year was CAASE. So for our listeners who aren't sure what I'm talking about, it's not a typical PDM conference, but rather a conference of simulation experts. And anyways, your topic there is this topic about multidiscipline optimization. I think a lot of people there are anxious to hear what companies like Cummins are doing. But before we dive into the details, some of our listeners may not even know what these words mean when you put them together. So could you start off with defining what is MDO and maybe even a little bit about how you're using it?
Sure. Yeah, so my formal definition is enabling cross-functional decision-making through the integration and optimization of diverse simulation models across the product lifecycle. And so a lot of words, what does it mean? So a visual for you, I think what we're trying to move from is having parallel functional lanes or parallel functional silos working on their individual aspects of the broader problem that we're trying to solve. And a lot of times those silos stay in their silos. They're really good at that. And a lot of times we make sequential decision making, or we make decisions sequentially throughout the product development cycle. And we don't share a lot of information across those silos. And we make assumptions, we hand over static sets of inputs. And so we're trying to move from that to this idea of how do you bring all these functions together? How do you model across those? So what it looks like is rather than just keeping a model in your own space and having these static inputs and trying to optimize within your space only, thinking broader in that, saying, how do I link to other models of other disciplines that actually have an information flow into my model, and then where does my information go? And bringing that together kind of helps us do and enable kind of cross-functional decision making.
So let's talk a bit about the disciplines. Is it a discipline of physics, or is it a discipline of organization, or a bit of both? I mean, what causes it to be parallel?
Well, I mean, historically, I think we've just gotten really good at, we need to work in our individual silos, and we need expertise there, deep expertise, to solve the different aspects of the problem. But naturally, when you're designing an engine, there's thermal guys, performance guys, there's structural guys. They all have to figure out how to work together and solve the problems, in a joint effort. But we've just kind of in the past, bucketed that up in different silos, and now we need to start thinking across those silos. How do we enable decision making across those and show the trade-offs that we're trying to manage? And fortunately, a lot of the, there's tools in the market and things that enable this type of activity, especially in the simulation space nowadays.
Well, that's one of the things you mentioned about in grad school and what computers can do for you. And then, of course, computers every year or so get better, right? I mean, that's the most amazing thing. And so maybe what you thought was expensive 10 years ago now all of a sudden is really inexpensive. So maybe elaborate, why is MDO so powerful, and why has it become so affordable? I mean, more and more people are doing it. What's driving that?
Sure. Well, our catchphrase for a while was, we can solve or iterate thousands of designs over the weekend. And, I think that still remains true. It just depends on the level of physics that you're modeling. But that was our catchphrase. And really what it means is we want to transition away from this manual design iteration, either in CAD and then passing over to the analysis tools and saying, how do we automate those different things, bring them together so that we can effectively explore the design space? And maybe then not even just explore the design space, really focus on the optimal trade space that exists between all these decision makers and constraints that we have. And so that's really the power of it, is you're taking these models that you would have used to help make decisions in the product development cycle, to answer maybe one discipline's key answers or optimize there, and just saying, how do I link that so I can inform the other decision makers around me about my constraints, and I can learn about theirs, and we can find that trade-off more effectively.
So you mentioned the typical performance stuff of thermodynamics and structural dynamics and so on. Did you also consider manufacturing practices or manufacturing preferences? Because like a car company, you guys are worried about volume.
Right.
Is that one of the things you're optimizing, is the machining side of it?
We're slowly getting there for sure, right? And especially when you're optimizing an individual component and you can play around with all the different dimensions of it, you can really then say, well, I didn't find just one design that meets the criteria. I've actually found a design space, and now I can get picky about, well, does this dimension really matter that much? How sensitive is my final result to that? And then you can start having those conversations with the manufacturing group about where is the preference, and iterate from there and see what are the ramifications on both sides when you try to come to an ultimate decision.
So for our listeners, another dimension of optimization is manufacturing cost, because clearly they could tell you, if three designs will perform equally, I want to choose the one that takes the least investment, as I go change my factory. So that's interesting. In your talk, you emphasized something I think is really important. You talked about people, process, and tools. And so often when we come out of school or we come out of our disciplines, we think the other way. We think tools, processes, and then people, right? So why did you emphasize people first?
I think it's the most critical piece. I came in, you're exactly right, Craig, with this passion around this tool set, this methodology. And what I realized was, yes, you can get some quick wins if you happen to have the right people with the right passion on the right projects, and you have the right tools. But to make sustainable change, you have to think broader. You have to think about how you define roles, how you evolve roles in order to enable the bigger vision. And then also, how do you enable it through process? One thing I've learned is you can make tremendous progress on one problem And then you could say, well, we'll never go back, right? I mean, we've
Right.
changed the world forever. And then a very similar problem comes the next day and we don't apply the same method. Well, why is that? You haven't changed the workflow, you know, and you
Mhm.
haven't changed the way people are operating. And you got to think bigger than that. And so, but to me, it's all about the people. You can have perfect tools, you can have perfect process, but you need the right people and the right roles kind of driving the bus.
Another phrase you used, and then we'll come back and talk a little bit more about people again, was democratization.
Mm.
So describe that, define it and describe it, and then maybe use some other terms. What do you mean by democratization? Is it mean that my business guy will understand simulation, or does it mean something else?
Well, I mean, yeah, democratization is kind of a dangerous word because it can mean so many things.
Okay.
But you know, what it means is, put simply in my mind, is bringing really powerful simulation tools that have been historically only accessible to really super deep experts, and bringing the capabilities of those tools to people who are non-experts, but doing it in such a way that they can use it to make better decisions. And
So does this mean they still need the analyst, the technical deep person to execute it, but they can now see the results and make decisions intuitively? Is that where you're going?
I think it all depends. I think there's
Okay.
levels of maturity in the democratization scale, right? I think there's one thing to say, you know, there's one thing to say it's completely democratized. The analyst is not in the loop. And I think we got to be very careful of that. I think what I'm talking about mainly is, how do we build that awareness and use these methodologies and the models to inform decisions outside, you know, of the places we normally have. And normally we've kind of constrained the use of all these tools, you know, CAD packages and analysis tools, really to detailed design questions and in the heart of the product development cycle. But what I'm realizing is, you know, these models have tremendous understanding and knowledge of our systems.
Right.
And they can be used throughout the whole product life cycle to help decision makers of all kinds make better decisions. And I think that's what we're trying to get to is one, we can take these methodologies that we use to automate and optimize on models, because we use models across the whole product life cycle of different kinds. But really thinking, how do we take the knowledge in these models and then push them out so we can make better decisions about product planning, or maybe then solve current product issues much faster, you know, and
Right.
if we have that vision, we can get better. So that's kind of the thing about democratization. But I do see some workflows where you have expert people building cross-functional models, and then you have an optimization tool wrapped around that, and you can deploy that to people that maybe are on the front lines, like trying to sell something, right? And then they can quickly say, here's the unique characteristics of my customer. What solution would be most viable given our suite of options, and how do I talk trade-offs with them? And that's what we can do.
Yeah, in the past, they would have written a specification document that would have taken 6 months to build a prototype, another 2 months to test it, and then before long, it's a year's gone by, and you're still talking about options. It is the cool thing. You said thousands of designs over the weekend. That is the most amazing thing to me, and as computers have gotten really cheap, really commoditized. You know, that we had some chief engineers for engines who they just loved it. They could look at combustion chamber choices to, you know, get after fuel economy and emissions. And before, we were lucky if we built 6, and we would do 5 or 6 in parallel and then choose the best. Well, now we can do 50 or 100 or 500 if it was really peculiar, right? So, cheap computers. How do you deal with the people that are resistant, either because they're maybe uncomfortable or maybe they're fearful for their job? How have you handled that?
Sure. Well, patience and perseverance, I think, you know. No, this is a really important point. You know, I quickly realized, like I said earlier, you can't come in with flashy tools and new ideas and expect to change the world overnight. I don't know if you want to. There's a reason why we have the people we have and the process that we have in place. You know, there's some really great elements of those things, or we wouldn't have been where we are as a company until that point.
Some of those designers, let's just say they were only designers, they have a lot of stored knowledge.
Absolutely.
It doesn't get maybe presented in a way that you can use it, but But the last time we had this piston ring problem, who solved it, right? You go to that guy and you say, well, you know, what was the real key? And at some point he says, oh, it was the material property of the piston ring. That's what really matters, right? Well, well, once you guys know that in analysis and simulation, you can say, oh, well, then let's go play with that, right? Let's play with that parameter.
Exactly.
Well, you wouldn't know that if that designer wasn't willing to share with you that experience, right?
Right.
So I never found that people resisted too long, but I always underestimated the fear. And I don't mean fear as in panic. I mean it more in they needed to know where they stood and what their role would be as we change this world, right? So before they built those 6 designs, now they're enabling us to go explore 600 designs. That's right. Well, as long as they understand their role, they probably will engage in that because they will be able to try out things they would have never tried out before because they just didn't have time.
Yeah, and I learned, Craig, pretty early on, I just need to embrace that reluctance or maybe that challenging, because what I realized is they're going to help you make the process better in the end. And then once they do that, they feel ownership of it, and then you've just changed the culture even faster, right?
Right.
And you're exactly right. One thing I wanted to make clear is, to me, there's people at Cummins that are walking MDO, studies. They're managing all these things in their mind.
True. In their mind, right.
That's right. And we don't want to replace them by any means. We want to augment them, in my mind, because we want to help quantify the qualitative knowledge that they have and they're walking around with, and then help them make a better decision faster. That's really what we're trying to get at here. And so that's how we've kind of dealt with that. Is this, there really isn't a competition. We're trying to just work better, take what was great about what we did before and just improve it even more. But don't strip off the stuff that made us great before.
Now you touched on it. I want to dive a bit more into quality management. You mentioned using it across the life cycle, and I think we're getting a good picture about how we use it up front in design. MDO can also be used to investigate field problems that maybe surprised everybody. Which probably means there's a missing load case or a missing misunderstanding of the way things are interacting. Do you have a favorite example of that where MDO just helped really nail the solution on a warranty issue without getting into the details of Cummins warranty?
I don't know if I have a great specific example, but where we find, right, when you're out there in the field and you're experiencing issues, you want to turn it into a robust design problem. What are all these variations that we didn't account for, whether it's a load case, like you said, maybe it's a dimensional tolerance that we got wrong. There's just a multitude of things, I mean, that could vary. And what we're saying is now is if you have these interconnected models that are now automated and have these inputs that really are those things that vary in the field, then we can go explore a multitude of combinations of what if scenarios and then say, how do we get more insight into that failure and come up with a more robust solution? I think that's in general how we're applying the tools.
Well, and that's good. The way you said that reminds me of the principles of design for Six Sigma. I mean, a large part of what you're doing is looking at those variation points. Absolutely. And another thing that comes up is something you thought you controlled turns out to be something you can't control, right? So this is what we do with dimensioning, right? Is we try to make sure we control a key dimension. Well, sometimes you find out you just can't do it, right? Yeah. Well, then you need to have some other remediation to handle that variance, right? So anything that improves understanding is good, and then of course any corrective action you have to apply. Now, so somebody's been listening for a few minutes and they've heard this MDO thing before, maybe because it's in the hallway discussion. Where can they go learn more? If this is new to them, besides finding your presentation at NAFEMS, where else can they go to learn more? And what do they have to do in terms of their skills? So assume they didn't have the college education about this, but rather they know about structural dynamics or they know about thermodynamics, but they don't know how the combination of those. Where do they go?
Well, I mean, there's a lot of great tools out there now and vendors that offer a lot of support in that domain. And that's kind of where, that was a big enabler for us, is getting connected with them. There's a lot of tremendous examples on the web that you can find as well to help you, think differently, understand what all this means. For me, my personal example is I have a structural background. So I started there. I said, okay, How do I automate the simulation I'm doing in the structural space? How do I optimize within that space? But where is the assumptions and inputs that I have to work with in my space come from? And then that starts to make you think, well, how is that modeled? And all of a sudden you say, well, what would it look like for these two models to talk? And then for our engineers to talk and to make better decisions. And so that's kind of how it cascades, right? The optimization expertise, I think that can be learned. A lot of these algorithms and things have been streamlined in such a way that you can come in as a non-expert and make some headway. So I think you just got to be curious about that. One, start with, how do I optimize in my own domain? How do I automate some of these things that are manual iterations today? And then once I've got that down, how do I then start talking to my neighbor that's providing inputs to my model and then iterating back and forth automatically?
Well, and you mentioned some of these optimization techniques. They've been around for a few decades. I mean, I was learning them when I was in school, and you and I are 30 or 40 years apart from each other. Maybe not 40. But the problem was always enough compute horsepower, right? And so now, and this has happened, we now have such available capacity, throughput of simulations, even HPCs in the cloud. I've been amazed by the cloud guys like Amazon and Oracle. They're supporting high performance computing in the cloud. So you don't even have to be a big company like the people you and I worked for. You could be a startup and still be able to do MDO on the weekend on, buying a few cycles of HPC from Amazon. Right. So it's interesting. So we're in these challenging times with COVID, and we're looking at each other's home office. How has this affected you? Have you been working at home since March, or
we have?
You're in Columbus, Indiana, or that area, I assume.
That's right.
Tell us how it's working.
Yeah, we've been working from home since mid-March, and honestly, the transition was quite smooth. We happen to have the right technology at the right time. Zoom is an everyday thing now, where it wasn't, but it was just like a light switch where we had it and we could use it. So we haven't really missed a beat in my mind, and that's been really cool to reflect on as a group, because we have people globally. We have people in the U.S., the U.K., India, China, all working together, all on this global team. And to think about how we've kept our productivity as high as we have has been pretty awesome to watch. So yeah, we've done okay.
What about the social aspect? Of course, if you're already distributed team, you already figured some of this out, right?
Exactly. Yeah, exactly. And it's actually, we've learned some best practices recently, just because we don't go to the office, that we can then make us more effective with collaborating with India, China, UK. So it's constant learning. But yeah, we've been doing that for a long time. But yeah, you got to get creative. We've been having like virtual coffee hours, early in the morning, where you would normally show up and brew your coffee and just, shoot the breeze. Now we're kind of trying to do that virtually. And so you just got to get creative. But yeah, we've just got great teams, really close knit people already, across our global team, and that's just helped us.
Well, Kevin, it's been a joy chatting with you. It's everything I would hope for. The MDO is here, and those of you that are listening that want to know more, remember Kevin's advice was just Google it. You'll find it. And it is, because it's so inexpensive, it's going to be common. I had one last thought for you. We talked a bit about manufacturing constraints, but the way we build engines and related things today is, a hunk of metal, and we mill it, right? We drill it, but maybe we bend something. But printing is upon us, right? Using additive manufacturing, that is the fancy word for it. So that too, MDO is one of those things you need in order to take advantage of additive manufacturing. So have you, without revealing corporate secrets, have you started working in that space as well, where you might have a part or two that are being printed now, being made differently?
Yeah, we were throwing the MDO flag straight away when we were thinking about additive, because it just opens up so many doors for you. Right. So yeah, absolutely, we're in there. We're applying these tool sets there, for sure.
And And everybody listening, this is typical. None of us talk about the details, but it's coming. So I think another reason to learn MDO is just how it will enable the fast adoption of things like additive manufacturing. The big sticking point, of course, is volume. But eventually people are going to figure that out like we have everywhere else. So volume production using those kind of machines, it's a little different than the way we do it today for drilling holes in blocks of iron or metal or whatever. So Thom, I'll hand it back to you.
Thanks. Hey, that was a great discussion. But Kevin, before I let you go, I got another question for you. So, you're a little bit younger than some of the people who we've interviewed. So you're still on the earlier side of your career, although you've been doing this for a while. I always like to take this back to some career advice for the people who are listening. So what would you tell people as far as, how to get established in their company, how to get ahead, how to grow, how to keep learning? Sure.
So a few things to think about. One, to me, and hopefully it was apparent through our conversation, is building relationships. We had a CTO that said engineering is a social exercise. And I really believe that. I've seen the fruits of that. And just getting to know other experts, other people that are working in different disciplines or even within your own, and building those relationships, trying to understand problems at a deeper level together, to me has been a huge enabler in my career. Another thing is find an area where you're passionate. I'm super passionate about these things. And so it gets me out of bed every day and just makes me excited to go to work and push forward and, deal with adversity or, challenges and head on. The other thing I've learned is just have high standards for the company you work for. Cummins is a great company that champions and grows its people, and I'm a product of that. And also having high standards for your mentors and your team. I have great mentors that push me to be better, make me think about things in a different way. And same goes with the team that I work on. All those things are super, super important for me.
Yeah, and I fully agree. One of the things when I go in and work with teams, I always tell them there's 3 buckets to success. That's your plans, kind of knowing what you're trying to accomplish as an individual and a team, your passion, and you clearly, you said that, but you also clearly have it because as you were talking with Craig about all this different stuff, I can see you on video. Obviously, everybody else is just hearing the audio, but your smile is infectious as you talked about all of this stuff. So you clearly have the passion. And then the final thing I teach everybody is it's all about the people. It's having the right mentors. It's being around the right team. It's building your network. It's how do you connect? And I think that advice goes a long way, no matter what stage of your career you're at.
Yeah. Hey, Thom, I think we got a new tagline. What was it, Kevin? Engineering is a social
exercise. I wrote that down.
It's a social exercise. Okay, everybody, all you introverts out there that don't like to be social, get over it and be social, right?
Because MDO is a way to help you, right? Through your models.
There you go. Through your models.
It's a vehicle.
It's an excellent summary. Well, thanks again, Kevin.
Thank you so much, Kevin. And Craig, it's always a pleasure to be with you and garner these really insightful, in-depth conversations with people in and around the PLM world. So, Craig, thanks for all you do for this podcast.
Okay, you're welcome.
Hey, and thanks.
Have a good day, both of you.
Yeah, and thanks everybody for tuning in and listening. I want you to come back next week because we're going to have more thoughts, ideas, and information in and around product lifecycle management. The Digital Enterprise Society, it is the place for those exchange of ideas around digital manufacturing tools. Check us out at digitalenterprisesociety.org.
You've been listening to the Digital Enterprise Society podcast. Learn more about what you've heard here today at digitalenterprisesociety.org. Join us again next week for more connection without boundaries and creation without limits.